statement. Look over here, look at me, I see you looking at me. And please remember, in this class, you should always remind yourself, you're not trying to learn how to do a problem. Okay, that won't help on a test that contains all brand new problems. You are trying to make sure you have the right flashcards and the right understanding. So we just do problems and just verify that your understanding is working, okay? This particular problem has tricked many, many students because it is common for students to, it's common for everybody, just kind of shift into automatic pilot and just start doing things without really thinking about what they're doing. So, raise your hand and tell me, what's the goal of the problem? What is the goal of the problem? You can't succeed in this class by doing stuff. You have to understand what you are doing. So what's the goal? Get more hands than that. You can talk to each other. What's the goal? So hands up, come on. What's the goal? What is the goal? Go with it.
Just to find the maximum acceleration.
Try to find the maximum acceleration. Very good. Point to the length. Please.
Quick question, isn't acceleration, is that the F prime? I can't remember.
You're doing great. You're doing great. Everybody listen to this. Hey, when you start talking about position, velocity, and acceleration, you want to avoid using the word F prime because it can cause mistakes. What Chris is remembering is related but not exactly the same. He's remembering from Unit 1 that if I have a formula, that can be used to find the position of a particle at any time, if I take the derivative of that formula, I'm finding the rate at which the position is changing, which is also known as the velocity. If I take the derivative of this formula or this one, they're the same thing. Now I have a formula that can be used to find the rate at which the velocity is changing. That's what you're remembering.
Yeah.
But you don't want to say F prime, that's not quite the same thing.
With going along with that, so maybe this is what you're saying for us not to do, but would we look at number 16 and say that that's like the prime formula, or like?
Oh, good comment. Hey, got it. 3 points for Elaine, actually. Hold up. No, it's super significant. Give one to Chris too, because it's kind of related. Look, it's very dangerous to memorize something as like, oh, that's the prime. Prime is relative. It all depends on what you started with. So it's not a good idea to say this is the prime. That will cause errors. Much better to say, well, this is the prime or derivative of position, but it's just velocity as well, so it's not necessarily the prime of anything. Just be careful with that. Please.
So, if it gives you the velocity, if you're looking at position and you want to accelerate it, it's a double prime, but like, since you start with velocity, it would just be the derivative of the acceleration, the first derivative.
Yeah, listen to Josh, I'll restate. Josh said that really, really well. The whole idea is not to look and say, oh, see, here's the difference. Autopilot is this, watch me. You memorize that acceleration is always the double prime. So you make the horrible mistake of like, oh, I need two derivatives, because they want acceleration. Like, that's not thinking, that's just doing work. Like, I see people go like this, like, you know what I'm talking about, right? Like, you're not thinking, you're just doing stuff. No, I don't need two derivatives of this, because the derivative of velocity is acceleration. So one derivative is sufficient. So I'm going to write A of t question this is actually a really, really simple problem. If you think as you work, if you just do stuff, you'll probably step in a trap and answer it incorrectly. Is everybody good to hear? Okay, all of you need to have this as a flashcard. It's been on the board for a couple of days. I've just changed it to fit this problem now. So this isn't exactly what was written before, but it's the same concept. Question? Please.
Is it okay, on the written test, if I just change the t to x? Because sometimes the t can just kind of confuse.
Good question. Everybody look over here. Everybody look over here. Chris is loading up today. No. On the written test, don't change t to x. Okay. Here's why, Abby. They're going to give you problems. Look. That will involve an equation for x of t. You're going to have x of x. If you change, yeah. Okay. So don't change t to x. Just get used to using t. I can sympathize with you. It bothered me when I first started doing it as well. I just got over my pain and just got used to doing it. So, other questions? Please,
when you say or when it has a relative mass, is that also like the critical points? That's just what I think.
Sorry. It's totally fine to memorize the min-max theorem as the max of A is going to occur at the beginning of A, which in this case is time equals 0, or at the end of A, which is time equal 3 in this case, or where A has a critical point. Yeah, this is a bit more specific, but either one should be fine. Yep, 2 points. Anybody else? So if this is the min-max theorem and the goal is to find the max of A, raise your hand and tell me what we should do. Hands up, come on. This is what, look, the purpose of calculus is not for you to learn calculus, in my opinion. Like, even as an engineer, I don't think the real goal is to get you to learn calculus. It's like, it's just calculus is a really good vehicle for learning to think logically. Everybody on the planet says, I'm a logical thinker, and you can prove them wrong really quickly. Because they don't think in a logical fashion. It's all random, and things don't tie together. You're just trying to connect ideas. We want to find where A is greatest. This tells us how to find where A is greatest. So what should we be doing? Hands up, come on. Talk to each other, I need more hands. And a spare voice if anyone's willing to loan it to. So tight. What was Sarah, silence.
Would we just factor it as much as we can and then make a sign chart?
Okay, hold on. Okay, please raise your hand. If you're thinking, raise your hand. If you're thinking we need to make a sign pattern chart of A, show me your hand. Show me your hands. Keep your hands up. Come on, keep them up. Who's thinking to make a sign pattern chart of A? Okay, make sure you mark down 2 points and then make note. That's wrong. Okay, mark down 2.
Get ready.
Mark down 2. Look out. Come on, look. Look. Extra credit for this question. Extra credit. I often say, we call it Danica's chart, we call it a sign pattern chart, so you'll link the two together. Don't make a sign chart of anything unless you have made a Danica's chart to know why you are doing it. Okay, that was supposed to be a question, it didn't work, so give yourself a point. Okay. So what Danica's chart should I make that will help me answer this question? Hands up, come on. What Danica's, don't do the sign chart until you make Danica's chart. Talk to each other. What Danica's chart should I make that will help me figure out this? Come on.
Put yourself in the you don't work because like when you want to find a point of inflection on the like if it's just like like if it's just f and a like just like measure as that. Once it's at point of inflection, once it goes negative to positive, and then a point of contact is yeah, so that's a zero. So we should go zero.
Why? Zach.
So you make a chart that says when velocity is increasing or decreasing, acceleration is possible.
So how many thought to make this Dennis chart? Show me that. Keep your hands up, come on, keep them up. Okay, mark down 2, but then make note they're trapping you. Okay, they're trapping you into the incorrect answer. Look. This is a valid Danica's chart. This is true. But this is not the chart. This is not the version of Danica's chart we need for this problem. Who knows why? Come on, hands. This is the wrong version. We don't need this version. Why? Why is this wrong? Gary?
Because we have to find A prime to find the
A. The goal of the problem is to find where A is greatest. If I have this Danica's chart, I'm going to be finding where B has a relative mass. The theorem says I want to find when A has a relative mass. We're trying to find where A is greatest. Wave at me if you feel confused. It's like the. Okay, we got to talk more. Marion, you're good at talking. Like, talk to me. That's a compliment. That's not. Okay, Marion, you do know that is a compliment. No, really, look at me. Everybody, I'm serious. I don't want to feel bad. I can't talk. In this class, the more you can talk, the better. Like it shows that it's the only way I can figure out if your thinking is correct or not. So please help me.
Okay, so I already did this one, and I'm just, because I did it that way. So we just do 2 derivatives then?
So what's the goal of the problem?
Find the maximum acceleration on the interval 0 to 3.
Good. So the min-max theorem tells you what?
That you can find the maximum at the end or beginning or when it has a relative max.
Right. Now look, come on, stay. You're doing great, right? Stay with me. Everyone look here, look. Okay. There's a reason why Reese Curtis was kind enough to make this sign. It's because of a problem like this one. You just absolutely cannot say words like graph, function, it. You have to be specific. So Marin has the right idea, but I need you to say what you said using the word A or B.
Okay,
So what's the goal?
to find the maximum acceleration on interval 0 to 3.
Good. How do we use the min-max theorem to do that?
So we need to find it on the acceleration. If there's a max on either the end or the beginning, or when the acceleration has a relative max.
Perfect. So how do we find, what Danica's chart do I draw to find where the acceleration has a relative mass?
So would it be like, I don't know if like there's another one after acceleration. When it does
So the thing to remember is you're doing super well, you really are. You're getting a tick in a second. Look. Derivatives are relative, so they go on forever.
Okay.
Go on. So what Danica's chart do I need?
You just need when acceleration is increasing to decreasing, and then whatever the next one is to be positive to negative.
So just A prime. Okay, does that feel better?
Yeah.
Do you feel like it makes sense?
Yeah.
Okay. This is what you need to be thinking. Talk to me, Ashley.
So does that mean that we are going to find the second derivative?
We need another derivative here. The word second to me doesn't really mean anything, because I'm just keeping track of the fact that this was the key to the problem, is recognizing that I've got to figure out when A has a relative mass. So doing this won't help me at all. Now, if you did it this way and got an answer, you likely stepped in a trap. Like they created an answer that works for that, but it's the wrong answer. Does that answer your question? Anybody else? Cool. Marion did an outstanding job on that. No, well done. Really well done. Back to Ashley's comment. Listen, hey, listen. Let's look. You'll do far better in this class. You'll avoid traps if you avoid simple things like saying, "Oh, we need two derivatives." Not necessarily. I do need two derivatives of this, but I only need one derivative of this. So that's just be careful. So here's A prime. So hands up, what do I do with A prime? Come on, hands. What am I going to do with A prime and Y? What am I going to do with A prime and Y? So, Justin.
Would you plug in 0 or B or T?
So stop for a minute. You made a mistake by kind of switching to autopilot. You're like, oh, we have an equation, let's plug numbers in. What is this equation for? On what? On A prime. What's the goal of the problem? Find where A is greatest. So I don't want to plug 0 and 3 into A prime. That won't tell me what the values of A are. 3 point. So what do I want to do here? Come on, hands. What do I want to do, Kylie? Side chart. Why am I making a side chart of A prime, Kylie?
Because you want to find when A prime.
There we go. There's my sign chart of A prime. Please.
Could you point it to 16 or 7?
Either way. Either way. It's your point. You need to talk about anything?
You gotta go big picture again, right? So you gotta.
Hold on. Hold on. Hold on. Hold on. Wow. Hold on. Yeah, there we go. Nice. Look. Once again, I know that they're going to fire me for saying this because I'm supposed to be a member of the math department. You're not taking calculus to learn calculus. You do calculus to learn how to just think in a logical way. So, logical thinking requires, logical thinking, I feel so bad for you. Look, logical thinking requires that we do a little step, then we go back to big pictures. Talk to me, Josh, like I'm a coffee line.
We did all this to find out. So you find like the derivative of A, so A prime, to find the A, to find where it's increasing.
Yes.
So now we need to just draw the graph of A, and then that's going to show.
Pause right there.
Yeah.
You're doing great. I'm complimenting you. Come on. Another tip for Josh. Come on. He said another key word. No one ever says that. No one ever says big picture except for me. Snap. Look. Come on, focus. Josh said something else. I don't think I've ever heard a student say. I say it over and over again. Like, no, who never says what I say? Like, I'm just up here rambling on. We make the sign chart of A prime so we can see what A will look like. That's the whole point. There's no other reason to make a sign chart of A prime. So I keep telling you, stop just doing stuff. Like, think about what you're doing. Look at me. Come on, look. If you think calculus is hard, here's a way to make it easier. Stop doing things and understand why you're doing it. You'll start remembering why you're doing it, it suddenly becomes a lot easier. I have a sign chart of A prime, so I can make, it's not really a graph, it's more of a sketch. I can whistle in a code and you can all understand me. Hands up, what does A look like? Come on, hands. Think with me, don't just watch me. What's the general appearance of A? Like, I don't know exactly what A looks like, but I don't need to. Just knowing the general idea is good enough. Carson.
It's a graph that has a relative max of 1.
Oh, be careful. So what does A do first?
Oh, it's decreasing.
Goes down.
Oh, so and then it starts decreasing at 1.
Yeah, I believe the teenage word would be, oh, snap. Is that right? Is that okay? You wouldn't like that, right?
No.
Okay, Lauren would not make me look foolish, right?
No.
You're awesome. It's really a challenge to teach for 15 years and figure out what the heck the current slang is. How many do this? Come on, 2 points, okay. That's A. So back to big picture. You did something little, go back to big picture. What's the goal of the problem? Hands up, come on. What's the goal? And what's the goal, Sarah? Find the max acceleration. So how does the picture help, Sarah?
We're finding the max.
So what is the picture telling you?
Okay, hold on. That the max is that one.
So stay with me. This is the great ticket giveaway day. Okay. You're making a mistake just because you're nervous now. Okay, this picture, Sarah, does this show the x coordinates or y coordinates of A or both? It actually shows both because the x's are depicted here and the y's are depicted as the up and down. Okay, when we say find the max of A, are we talking about the maximum y value or the maximum x value? Y value. Which of these y values would you say is highest? So the highest point's not going to be here. Does that make sense? How many knew that the highest point of A would have to be here or here? 2 points. That's why we do the sketch. That's why we do the sketch.
Let's say it's going from positive to negative, so we know that A is negative, so it's going to decreasing. How would we find that like exact point? Is that
Hold on. So you want me to draw a picture of A. What do you want me to draw? It's a good question.
like increasing and decreasing?
Like that?
Yeah. Just
You know
like
what-
how would we find that point?
That point right there?
Yeah.
Look up.
How come I just learned this?
You're doing great. No. Listen. The thing a lot of you don't understand is that the best way to learn in this class is just every time something in your head says that doesn't make sense, you speak up. If you'll always do that, you'll just get better and better. It's when you ignore the feeling that you don't improve. So no, keep talking. Look. The key is the sign chart. You tell me, when did A prime change from negative to positive? At time equal 1. So I know exactly where this point is. It's at a t value of 1. And if I want to find the acceleration, I just go plug 1 into the acceleration.
But not into the A prime?
No, because, look, these are really good questions. Come on, stay with me. Come on, don't drift. Focus. Learn that in college you're going to have to concentrate the whole period. Okay? Right here, we've got a picture of A. We've got a sign chart of A prime. The question was, it's very valid. Well, right here, time is 1. why not plug one into this formula? I already know what happens when I plug one into this formula. Who knows? Who knows what happens when I plug one into this formula? Hands up, come on. What happens when I plug one into this formula? What am I going to find? What am I going to find, Luke?
0.
Yeah, we've already written it down. We already know that. If I plug in one to this formula, if I plug one into this formula, the result is 0. How many knew it? Points. Yeah, that's not the goal. The goal is to figure out values of A. So if I have a low spot, I plug it into A to find out how low A is. If A looks like this, I'll know that this is time 1 as well. And I'll just plug it into A to find out how high it is.
Okay.
Is that your question?
Yes, yeah.
Good work. We'll continue to read to the giveaways. 30 more minutes, I can make it. Okay. Other questions? Okay, we gotta go back to big picture. What are we supposed to do now? Hands up, come on. What's the goal of the problem? What's the goal? What are we trying to figure out, Lori?
So we know that the max is to get these are the endpoints.
So we know that really, right here, the time is 0, and the acceleration is that. Over here, time is 3, and the acceleration is this. Here's where a lot of people make another mistake. Because they're not thinking as they solve the problem, they just think they have to do stuff. They'll go, oh yeah, endpoints, 0 and 3, and they'll plug them into here. Yeah, I laugh because like it's not thinking at all. It's just doing stuff. You laugh because you know you've done it. Right? Yeah, it's like at school you used to do stuff, you know, whatever. No, you gotta plug them into A. Question. Once I plug those values into A, I'll see that one of them is higher. Then I'll know the highest acceleration. Question? Good work. Good work.